Balloons, ubiquitous in celebrations and decorations, come in various shapes, sizes, and colors. In earlier days, balloons were made of dried animal bladders. Imagine those at a party or celebration. That didn't stay the norm though. In the 19th century, someone finally came up with rubber balloons, and those were eventually replaced too with latex. Since latex is incredibly elastic and can stretch up to 7 to 8 times its size, there was merit to using it as a material. Now the balloon industry is valued at 300 million USD. But how are they made? Raw natural latex is a white or yellowish opaque liquid, similar in appearance to milk. Latex is the secretion of certain plants, in particular the hevea tree originally found in Brazil. The most important sources of natural rubber today are plantations in Malaysia and Africa. Producers of rubber must harvest the raw material from these trees. Skilled workers, often called tappers, make incisions in the bark of the rubber trees using special tapping knives. These incisions allow the milky white latex sap to flow out of the tree and into collection cups attached to the trees. The latex sap, which resembles milk in appearance, gradually fills the collection cups over several hours. Tappers visit the trees periodically to collect the latex, typically every 1 to 3 days, depending on factors like tree health and climate. Once collected, the latex undergoes treatment to prevent coagulation, which would render it unsuitable for further processing. Ammonia is commonly added to the latex as a preservative, maintaining its fluidity during storage and transportation. Various additives are mixed into the latex to improve its properties and performance in balloon production. Antioxidants help prevent degradation of the latex due to exposure to air and light. Vulcanizing agents are added to promote cross-linking of polymer chains during curing, enhancing elasticity and durability. The latex undergoes a concentration process to remove excess water and increase the concentration of rubber particles. This can be achieved through centrifugation, where the latex is spun at high speeds to separate solids from liquids, or evaporation, where heat is applied to remove water. Then, the latex is transported from production facilities to balloon manufacturing plants using specialized containers or tanker trucks. During transportation, care is taken to prevent exposure to extreme temperatures or mechanical damage, which could compromise the quality of the latex. At the factory, the latex is mixed with dye and filtered through cheesecloth to prevent any lumps. Agitators at the bottom of the tank mix it up for 15 hours. This not only distributes the color but also keeps the latex active, which would otherwise become congealed. This factory produces balloons in as many as 53 different colors. The molds used to shape round balloons in a factory look like neatly arranged upright baby rattles traveling on a tray. They might be set out in a grid of, say, 3 rows of 11 molds each. This tray of molds will roll from station to station, some of which contain special fixtures to flip the tray so it can be dipped into various chemicals. However, before any of this, the balloon forms or molds are sprayed with hot water to clean them as they pass through a system of rollers. These forms are then flipped and dipped into a tank of coagulant. The coagulant also contains an electrochemical charge. When the balloon forms with the coagulant interact with the tank containing the colored latex, they attract the latex solution, resulting in a thin uniform coating over the balloon molds. The longer the forms are left in the tank, the thicker the coating that sticks to them. For balloons, a very thin layer of latex is desired, so the forms are immersed only for a few seconds. The forms must be inserted and removed at carefully controlled speeds to avoid trapping air bubbles and to achieve an even, thin coating. The balloon forms are then moved on a conveyor towards spiraling brushes. These brushes roll up the bottom of the balloons, creating lips. These grips make it easier for people to grip the balloons and inflate them. The balloon forms are then dipped into a hot water bath. This step is important because it cleans the latex, including getting rid of the protein that causes latex allergies. The hot water also triggers vulcanization, which rubberizes the latex. This process, discovered completely by accident by Charles Goodyear, revolutionized the rubber industry. It significantly enhances the elasticity and durability of rubber. Before vulcanization, raw rubber is relatively soft, sticky, and prone to deformation and degradation under various conditions. After vulcanization, rubber becomes more resilient and can withstand greater stress, making it suitable for a wide range of applications. The next step is to strip the balloons from the molds. To make the process easier, the forms are dipped into a mix of talcum powder and water. This will allow them to be seamlessly stripped off the form. Finally, it's time for the forms to be stripped of their latex coverings. As the forms pass through this machine, air jets fill the balloons with air. As the balloons fill with air and start to come out of the form, they're grabbed by rollers at the top that roll them away from the forms. The stripped balloons then topple onto a conveyor belt. They're received by a worker who piles them onto an industrial washing machine and then adds a cleaning solution. The machine heats to 71 degrees Celsius. This process not only cleans the balloons but also completes the vulcanization of the latex. Balloons undergo pressure testing to ensure they can withstand inflation without bursting. This involves inflating balloons to their maximum capacity and subjecting them to specified pressures for a predetermined duration. Quality control measures also include assessing color consistency across batches to meet customer expectations. The balloon manufacturing environment itself must be strictly controlled in order to achieve high quality and consistency. Throughout the manufacturing process, computer-based instrumentation records and controls air humidity, air temperature, latex tank temperature, the temperature in the ovens, dryers, and other parameters. The latex and other chemicals used in the process must be carefully formulated for specific properties and carefully maintained. For example, the latex must have a certain viscosity and speed of drying. The tanks in which it is held must have devices to keep the latex circulating to avoid forming a skin and to prevent ingredients from settling. After passing quality control checks, balloons are grouped and packaged according to customer requirements. Packaging may involve individual wrapping or bunching balloons together. Packaged balloons are stored in controlled environments to maintain their integrity. Careful handling during transportation prevents damage and deformation. The next time you're at a party and spot a balloon, you can truly appreciate the amount of work that goes into making one. If you like this video and want to watch more, check out our channel. Before hot air balloons, various cultures had envisioned human flight. However, it wasn't until the 18th century that humans made a successful effort to achieve controlled flight. The invention of the hot air balloon is primarily credited to the Montgolfier brothers, Joseph Michel and Jacques-Étienne Montgolfier, French paper manufacturers. Their success paved the way for an interest in aviation across Europe. But have you ever wondered how hot air balloons work, and most importantly, how are they even made? Hot air balloons are based on a very basic scientific principle. Warmer air rises in cooler air. Essentially, hot air is lighter than cool air because it has less mass per unit of volume. The hot air balloon uses three things in order to put this principle into use and achieve flight: the envelope, the actual balloon which holds the air, the burner, the unit that heats the air inside the envelope, and the basket, where the passengers and pilot stand. To inflate a balloon, the envelope is stretched out on the ground and attached to the basket and burner, all of which are laying on their side. A small gasoline-powered fan blows air into the balloon. Then the burner is turned on and the air in the envelope is heated. The hot air rises, lifting the balloon upright. Modern hot air balloons heat the air by burning propane, the same substance commonly used in outdoor cooking grills. As winds at varying altitudes blow in different directions and at different speeds, all you have to do to steer a balloon is to climb or descend to an altitude where the wind is blowing in the direction you want to go. To descend, the pilot allows the air to cool. The average duration of the flight by air balloon is 1 hour, even though technically it could fly 2 to 3 or even more hours. Now on to the manufacturing process. First is the envelope. The envelope is the most prominent feature of a hot air balloon, usually made from durable yet lightweight fabrics such as nylon or polyester. Manufacturers choose materials with high strength to weight ratios and resistance to heat and UV rays. Nylon is commonly used for its lightweight and durability, while polyester can be used for high heat areas like the mouth of the envelope. The pattern for a hot air balloon is complex, often requiring CAD or computer-aided design software to ensure precision. The pattern is divided into gores, sectional panels that form the balloon's shape when sewn together. There are three main types of gores: vertical, horizontal, and diagonal. Diagonal panels are the most economical because they waste the least amount of fabric. Manufacturers determine the balloon shape and size during this phase, considering factors like aerodynamics and aesthetics. There are two prevalent balloon shapes: teardrop and round. The teardrop can climb faster using less energy, but the round-shaped balloon uses less fabric, thereby having less surface area to heat. With the pattern designed, fabric pieces are cut using computer-guided cutters to ensure precision. This step is crucial to ensure a seamless fit when assembling the balloon. The cut pieces are sewn together, forming the balloon's distinct shape. Industrial sewing machines are used to create strong seams that withstand the stress of inflation and heat exposure. Double or triple stitching is common for added durability. With the envelope sewn, other components are added to complete the balloon's structure. Load tapes are strong, durable strips sewn into the envelope to distribute the balloon's weight evenly. They run vertically along the seams, providing additional strength. The parachute valve is a critical component that allows the pilot to release hot air, controlling the balloon's altitude. This valve is located at the top of the envelope and is usually attached with reinforced stitching and grommets. Suspension cables connect the envelope to the basket or gondola. These cables are made from steel or other high-strength materials and are threaded through reinforced sections of the envelope, typically along the load tapes. The basket or gondola is where passengers and the pilot stand during the flight. The basket frame is typically made of wicker, rattan, or aluminum for strength and flexibility. Wicker is popular for its classic appearance and lightweight properties. The frame is constructed by weaving the materials into a sturdy structure. To ensure safety and durability, baskets often have reinforced corners and edges. Metal or wooden bracing may be used to enhance strength. The basket's floor must be robust enough to support the weight of passengers and equipment. It is usually made from sturdy wood and is secured to the basket frame. Suspension cables connect the basket to the envelope, providing a stable platform for the passengers. These cables are secured to the basket with metal fixtures or reinforced loops, ensuring a strong connection. The burners are responsible for heating the air in the envelope, allowing the balloon to rise. Burners are designed to produce a powerful and controlled flame. They consist of a fuel tank, fuel lines, and a burner head. Propane is the most common fuel source, as it burns hot and clean. The burner head is where the propane is ignited to create a flame. It includes a burner tube and a pilot light for ignition. The burner head must be robust and heat-resistant to withstand prolonged use. Control valves allow the pilot to adjust the flame's intensity. These valves are typically located near the basket for easy access during flight. They connect to the burner head via flexible fuel lines. The burner frame holds the burner head in place and connects it to the suspension cables. This frame is usually made of metal for strength and heat resistance. With all the components prepared, the final step is to assemble the hot air balloon. The suspension cables connect the envelope to the basket, creating a stable structure. The attachment points are carefully reinforced to ensure safety during flight. The burners are secured to the basket and connected to the suspension cables. The fuel tanks are also attached, ensuring a safe and stable setup. Before a hot air balloon is deemed flight-ready, thorough checks are conducted. This includes testing the burners, inspecting the seams, and ensuring all connections are secure. A test inflation may also be performed to check for any leaks or weaknesses. Environmental concerns are shaping the future of hot air balloons. Traditional hot air balloons use propane burners, which have a carbon footprint. Therefore, researchers are exploring the use of greener fuels like hydrogen or biofuels to reduce emissions. Systems are also being developed that use solar power to heat the air instead of gas. Worldview Enterprises, a tourism company, is designing hot air balloons that will take passengers to the edge of space. This will provide a more affordable way of experiencing the upper reaches of the Earth's atmosphere than rocket-powered trips. Passengers will ride in a comfortable capsule suspended beneath the balloon, which takes several hours to rise to almost 20 miles high above the Earth. From there, passengers can spend 2 hours enjoying breathtaking panoramic views of planet Earth before gently descending back to the surface. That's not all. Project Loon is a division of Google that uses unmanned hot air balloons to provide internet access for remote areas. Balloons are deployed 20 kilometers above the ground, with each one providing internet coverage for an area of about 40 kilometers in diameter. The balloons can also provide mobile phone access. If you liked this video and want to see more like it, check out our channel.